Good day, everyone. My name is Sheila May de los Santos, and today I will discuss about the standard deviation, which is the statistical measures that shows how spread out the data values are from the mean. Standard deviation tells us how close or how far the values are from the average. A small standard deviation means the values are close to the mean, while a large standard deviation means the values are widely spread. There are four basic steps in finding the standard deviation. First, find the mean. Second, subtract the mean from each value and square the result. Third, find the mean of squared differences. Finally, take the square root. Let us use an example. Sum has 20 rose bushes, and each bush has a certain numbers of flowers. These values will be used to calculate the standard deviation. Step 1. Computing the mean. To find the mean, we add all the values and divide by the total number of data points, which is 20. The total is 140, and dividing by 20 gives us a mean equal to 7. Step 2. Subtract the mean and square. Next, we subtract the mean from each value and square the results. This shows how far each value is from the mean. For example, 9 minus 7 equals 2, and squaring it gives 4. Step 3. Finding the variance. We then add all the squared differences using sigma notation. The total is 178. Dividing this by 20 gives 8.9, which is called the variance. Step 4. Finding the standard deviation. To get the standard deviation, we take the square root of the variance. The square root of 8.9 is approximately 2.98. This is the population standard deviation. The data we used earlier represents the entire population. However, sometimes we only use a sample of the population, not all the data. When dealing with sample data, we use a different formula. Instead of dividing by n, we divide by n minus 1. This adjustment is called Bessel's correction. Using the sample values 9, 2, 5, 4, 12, and 7, the mean is 6.5. After subtracting the mean and squaring the results, the sum of the squared differences is 65.5. Dividing by n minus 1 gives us a sample variance of 13.1. Finally, we take the square root of the sample variance, and the square root of 13.1 is approximately 3.62, and this value is the sample standard deviation represented by the symbol S.